If you ask 10 supply chain leaders what supply chain technology management means, you'll get 10 different answers, each of them partially right and none of them complete. That's because it isn't one tool or even one stack. It's the discipline of choosing, connecting, operating, and evolving a constellation of systems, data, and devices so that materials, information, and money move with fewer surprises and better outcomes. It's strategy and plumbing, change management and governance, sensors and servers, dashboards and decision rights. Above all, it's about turning technology into capability, making sure every byte and bolt serves a business purpose, better service, lower cost, higher resilience, less risk, and a lighter footprint on the planet. Start with the simple truth that almost every supply chain problem is a coordination problem masquerading as something else. We buy too much or too little because we can't see true demand and supply constraints in one place. We spend too much on freight because we plan late and buy capacity on the spot. We carry excess inventory because we don't trust forecasts or lead times. We ship late because the warehouse is firefighting. Technology doesn't make these realities disappear, it makes the system visible and governable. Enterprise resource planning gives you transactional backbone. Advanced planning systems help align demand and supply. Warehouse and transportation management systems orchestrate day-to-day execution. Product lifecycle systems manage the digital definition of what you're making. Manufacturing execution ties digital plans to physical operations. Layer interfaces on top, APIs and EDI for partner connectivity, IoT sensors for condition and location, control towers for end-to-end visibility, and you begin to have a nervous system. Add analytics and machine learning, and you get reflexes, the ability to sense, predict, and react. But before diving into the alphabet soup, it helps to anchor on outcomes. What are you trying to achieve in the next 12 to 24 months? Faster order promise accuracy? Reduced stockouts by 30%? Lower air freight by half? A reliable track and trace chain for regulatory compliance? Scope 3 emissions visibility? The magic isn't in standing up yet another system, it's in choosing the smallest set of changes that unlocks those outcomes and sequencing them so value shows up early and often. It's tempting to blueprint an entire digital future and then spend years implementing it. The more effective pattern is a rolling roadmap. Prove value with a few high-impact use cases, scale what works, prune what doesn't, and keep your architecture flexible so you can plug in new capabilities without ripping out your core. The core platforms matter because they define your center of gravity. An ERP system is still the accounting of truth. Orders, invoices, receipts, bills of materials, routings, inventory balances. Advanced planning bridges strategy and operations, demand forecasting, supply planning, production scheduling, available to promise and capable to promise, scenario analysis. Execution systems are the muscle. Warehouse management for receiving, put away, picking, packing, shipping, transportation management for carrier selection, tendering, tracking, freight audit, and payment. Order management for orchestrating which node fulfills which order. Manufacturing execution for capturing actual production, yield, and quality. Product lifecycle systems hold the master definition of the product and engineering changes, a critical thread linking design decisions to supply chain impacts. If each of these platforms is a star, your integration fabric is the constellation pattern that makes sense of them. Integration is where technology management earns its keep. Many companies still rely on EDI with key trading partners because it's ubiquitous and battle-tested. APIs bring speed and richness, especially for real-time events like shipment status or available stock checks. Event-driven architectures let you react to things as they happen. A drop in inventory below a threshold can trigger replenishment. An exception in a warehouse can reroute a pick, a late vessel can reshuffle allocations. An integration platform as a service can help manage this complexity with reusable connectors, transformation maps, and monitoring. But integration isn't just technical. You need data standards and semantics so that shipped means the same thing everywhere, so that a location or item identified by one system lines up with another. That's where master data management earns its unglamorous, essential reputation. Clean product, customer, supplier, and location data is the difference between pretty dashboards and dependable decisions. The data layer is evolving quickly. Data lakes and lakehouses make it feasible to ingest transactional, sensor, and external signals in one place: orders, inventory movements, GPS pings, weather, port congestion indices, social trends, and then push insights back into operational systems. A control tower isn't just a visibility screen. The better ones blend data, analytics, and workflows so you can detect an exception, assign it, and resolve it within the same space. Digital twins of the supply chain go further, creating a simulatable model of your network, nodes, lanes, lead times, capacities, costs, and letting you ask, what if, before you act? What if that port closes for 2 weeks? What if we shift 15% of volume from air to ocean? What if a supplier's yield drops by 5%? When these twins are connected to real-time feeds and governed by good assumptions, they become strategic tools that converge planning and execution. Machine learning and optimization are finally moving from slideware to daily work. Demand sensing models can pick up short-term signals, weekend weather, promotion timing, online traffic, to improve near-term forecasts. Causal models that explain what drives demand help planners trust the numbers. Optimization engines can generate production schedules that respect constraints and minimize changeovers, route trucks to hit time windows with fewer miles, and set safety stocks that balance service and inventory. Anomaly detection can flag when a shipment's expected arrival is drifting for reasons a human wouldn't see early enough: vessel speed changes, route deviations, or patterns correlated with past delays. There's healthy caution to keep in mind. Models need clean, relevant data. They need monitoring because the world changes, and they need explainability so humans can understand and override when needed. The most successful deployments use AI as co-pilot, not autopilot, suggesting actions, quantifying trade-offs, and leaving authority with accountable people. Hardware and edge technology are part of the story too. In warehouses, goods-to-person systems, autonomous mobile robots, and automated storage and retrieval can boost throughput and address labor constraints, but they introduce new planning problems: balancing human and robotic work, maintaining uptime, and integrating with the WMS so orchestration is seamless. Computer vision can verify picks, count pallets, and improve safety by monitoring zones. On the transportation side, telematics and IoT devices track location, temperature, humidity, and shock, vital for cold chain and high-value goods. Satellite ice data enriches ocean visibility, while geofencing enables precise proof of delivery in last mile. Connectivity choices: cellular, LPWAN, satellite, affect battery life, coverage, and cost. Edge computing can process sensor data locally to reduce latency and bandwidth, triggering alerts when conditions deviate rather than streaming everything back, which matters in remote or bandwidth-constrained operations. Traceability has moved from nice to have to a license to operate in many sectors. Retailers want end-to-end provenance. Regulators require proof that goods weren't produced with forced labor, and consumers are asking where products came from. Achieving traceability means agreeing on identifiers, capturing events at handoffs, and keeping that chain intact across organizational boundaries. Standards like GS1 identifiers and event data models are pragmatic enablers. Some firms are piloting distributed ledgers where multiple parties can write tamper-evident records. Whether or not you use blockchain, the challenge is less about the ledger and more about data capture quality, partner participation, and scaling processes so the information is accurate, auditable, and not crushingly expensive to maintain. Technologies that lower the cost of capturing events, RFID, computer vision, mobile scanning, often deliver more value than fancy ledgers if your goal is reliable traceability. Sustainability metrics are increasingly embedded in supply chain tech stacks. Measuring Scope 3 emissions requires pulling activity data from suppliers, carriers, and internal systems and applying appropriate emissions factors. Route optimization that explicitly trades off cost, time, and carbon intensity can guide smarter mode and lane choices. Packaging design tools can model material use and recyclability alongside cube utilization. Supplier portals are adding sustainability scorecards and corrective action workflows. Product passports are emerging concepts where materials and repairability data travel with the product across its life. The trick is to connect sustainability to operations so it's not a parallel spreadsheet exercise. When planners see the emissions impact of an air expedite or the benefits of consolidating loads, behavior changes. When procurement sees supplier sustainability alongside price and quality in sourcing events, selection criteria broaden without becoming arbitrary. Security and resilience are non-negotiable as supply chains digitize. Every integration point is a potential ingress for cyber risk. Zero trust principles, network segmentation, multi-factor authentication, and disciplined identity and access management aren't IT-only topics, they protect your ability to ship product. Operational technology is converging with IT as factories and warehouses connect machines to networks. That raises the stakes on patching, intrusion detection, and incident response that understands both PLCs and APIs. Vendor risk management matters because a vulnerability in a logistics partner or software vendor can cascade into your operation. Business continuity plans have to account for tech outages. What's your fallback if the WMS is down? Can you pick and ship on paper for a day without chaos? How do you reconcile after? Disaster recovery drills, backup strategies, and clear RTO, RPO targets shouldn't be backburner items. In a world where a single misconfigured certificate can stop a distribution center, operational excellence includes digital hygiene. One of the hardest parts of supply chain technology management is modernization without meltdown. Many companies are sitting on decades-old, heavily customized systems that work, up to a point. Replacing them isn't just a technical project, it's a heart transplant while running a marathon. The path forward is usually a mix of strangler patterns, wrapping legacy with APIs, extracting capabilities to more modular services over time, and selective replatforming where the benefits clearly outweigh the risk. Keep an eye on the long-term cost of customization. Configuration and extensibility are friends. Deep custom code is debt. A composable architecture, where you assemble capabilities from interoperable components, makes it easier to swap pieces as needs evolve. That composability is cultural as much as technical. It requires product-oriented teams who own outcomes, not just project teams who disband at go live. Governance is the scaffolding that keeps everything aligned. Start with decision rights. Who owns global process design and standards? Who can approve deviations for a local market? Who prioritizes the backlog for your planning platform? A center of excellence can steward process templates, data standards, and training while enabling local autonomy for what truly needs to be different. Data governance, assigning data owners and stewards, defining quality rules, and monitoring adherence, keeps the foundation from crumbling. Architectural governance makes sure new tools fit the blueprint, use standard integration patterns, and don't reintroduce silos. Vendor governance matters too. Clear service levels, escalation paths, and joint roadmaps with your strategic providers avoid surprises and help you influence product direction where it matters. People and change management often determine whether technology delivers outcomes or gathers dust. You need super users who bridge business and tech, planners who can interrogate a model rather than just accept it, warehouse leads who understand how a robot workload intersects with human labor. Training isn't a one-off, it's ongoing, role-based, and practical. Communications should focus on why the change matters to the business and to the individual, what pain it relieves, what new capabilities it unlocks. Measuring adoption is as important as measuring uptime. Are planners using the new forecast consensus process? Are buyers acting on supplier risk scores? Are dispatchers trusting dynamic ADAs and re-tendering appropriately? Celebrate wins where technology and process change create visible improvements. Those stories build momentum. Selecting technology partners is a craft of its own. The right answer depends on your starting point, industry, scale, and appetite for change. Resist the urge to evaluate tools in isolation. Design test scenarios that reflect your reality: messy data, edge cases, seasonal spikes, constrained capacity. Runtime boxed pilots that prove not just a feature but an outcome: fewer stockouts in a pilot region, improved tender acceptance on a few lanes, faster cycle times in a test warehouse zone. Watch for signals of partnership quality: responsiveness, transparency about roadmap and limitations, willingness to co-create and integrate in your environment. Total cost of ownership is more than subscription fees. Factor implementation, change management, integration, training, upgrades, and the cost of delay if adoption lags. Contracts should reflect the criticality of the service with clear SLAs, performance credits, data ownership clauses, and exit paths. One topic that sparks a lot of debate is build versus buy. For most companies, buying core platforms and building tailored glue and differentiating analytics is the pragmatic path. You don't need to invent a WMS unless your operation is truly unique. But you might build an allocation engine that reflects your specific gross to net rules, customer commitments, and marketing promises, or you might configure a platform deeply and extend it with microservices. Low-code and no-code tools let citizen developers automate workflows and create simple apps, which can be a force multiplier if governed well. Without guardrails, they create shadow IT and brittle processes. The art is enabling speed without losing coherence. Provide shared services, templates, and review gates that keep solutions secure, maintainable, and aligned. Planning deserves a special lens because it's where technology can quietly reshape behavior. A modern planning stack that supports integrated business planning pulls together demand forecasts, supply constraints, and financial targets into one conversation. When the monthly cycle is supported by good scenarios, the debate moves from whose number is right to which plan best meets our strategy under uncertainty. Available to promise and capable to promise engines connect planning to execution in real time, letting customer service quote dates that reflect actual constraints instead of wishful thinking. Allocation rules codify priorities during shortages, making tough choices transparent and consistent. The human element is crucial. Planners still need to recognize when models are being gamed, when data is stale, and when an emerging signal hasn't yet appeared in the dashboard but is real on the ground. Execution technology is where small frictions multiply quickly. In warehouses, slotting strategies powered by data can shave seconds off thousands of picks. Pick path optimization, wave versus waveless strategies, and labor management tied to fair standards can lift productivity without burning people out. Yard management systems that orchestrate trailer movements and gate appointments reduce dwell and demurrage. In transportation, market volatility makes procurement strategy and TMS sophistication matter, blending contract and spot, leveraging digital freight platforms when it makes sense, and using dynamic pricing and tendering rules to keep acceptance high. Accurate predicted ATAs, improved by ingesting carrier data, telematics, and third-party feeds, allow proactive replanning. Freight audit and payment automation can recover real money and prevent leakage. On the last mile, route optimization tied to real-world constraints, proof of delivery capture, and customer communication reduce failed attempts and improve satisfaction. Reverse logistics is often the neglected sibling, especially in e-commerce heavy businesses, and technology can unlock value here too. A returns portal that guides customers to the right path, disposition engines that decide repair, refurbish, restock, or recycle based on condition and economics, and integration with re-commerce channels can turn a cost center into a recovery machine. Adding serialization and grading standards improves consistency and downstream analytics, and tying returns data back into product design and quality loops prevents repeat issues. Risk sensing platforms are rising in importance as supply chains expand their field of view beyond Tier 1 suppliers. Tools that map multi-tier networks using public filings, shipment data, and supplier self-reporting can reveal concentration risks before they bite. Event monitoring, natural disasters, port strikes, regulatory changes, cyber incidents, overlaid on your mapped network gives early warnings. But tech alone doesn't make you resilient. You need playbooks. What to do when a sub-tier supplier in a critical region goes offline. What substitutions are viable? Who decides? How customers are informed. Scenario models that quantify time to recover and time to survive. Expose where buffers or dual sourcing are worth the cost. The same platforms can help with regulatory compliance where traceability and sanctions screening are required. Finance has its own technology angle that weaves through everything. Total landed cost engines help make better sourcing and fulfillment choices by capturing duties, taxes, freight, and handling. Cost to serve analytics break profitability down by product, customer, and channel, revealing where fast and free shipping is silently eroding margins. Supply chain finance platforms and dynamic discounting programs can improve working capital for both you and your suppliers, especially when tied to real-time shipment milestones. When finance, planning, and operations are looking at the same data, the organization stops arguing about the past and starts deciding about the future. None of this works without clear metrics. Technology can produce a forest of KPIs. You need the few that guide behavior. On time in full and perfect order rate capture reliability. Forecast accuracy matters, but forecast value add, how much the forecast improved decisions over a naive baseline, prevents number chasing. Plan adherence, inventory turns, and service level attainment tie planning to outcomes. Transportation cost per unit and tender acceptance rate reflect logistics health. Emissions intensity per shipment turns sustainability into a daily metric. The point isn't to admire the dials, it's to connect them to actions. When a control tower flags an at-risk shipment, what's the standard work? When forecast error spikes in a category, who investigates and how quickly? Technology shines when it pulls the signal out of noise and puts it into the hands of the person who can act. There's an organizational design question at the heart of technology management. How do you structure teams to own and evolve capabilities? Borrow from product management. Instead of projects that end at go live, create product teams for planning, fulfillment, transportation, supplier collaboration, data platform, and so on. Give them clear missions, KPIs, and backlogs. Staff them with a blend of business and technical talent. Align them with an architectural runway that limits divergence but leaves room for innovation. This model supports continuous improvement and avoids the boom-bust of big bang programs. It also helps with talent retention. People prefer to own something meaningful rather than hop between temporary projects. On the horizon, a few trends are worth watching with clear eyes. Generative AI is entering the planner's cockpit as a conversational interface and assistant, surfacing anomalies, drafting root cause analyses, proposing mitigation plans, and even generating playbooks. This can reduce the cognitive load and onboard new talent faster, but it must be governed so that reasoning is transparent and recommendations are grounded in the company's data and policies. Composable supply chain suites are maturing, promising faster time to value and easier upgrades. The convergence of engineering and supply chain data, the digital thread from design through manufacturing to after-sales, will make postponement, service parts planning, and circular models more efficient. Regulatory tech will expand as product passports, carbon border measures, and labor traceability rules bite. Expect more demand for embedded compliance and auditable trails. Edge autonomy, robots, vision systems, drones for inventory will keep climbing the adoption curve, shifting the labor mix and raising the importance of robust wireless, safety, and orchestration. For all the sophistication, the principles remain refreshingly simple. Start with the problem, not the tool. Make data trustworthy and shared. Design for both efficiency and resilience. Prefer configuration over customization. Automate what's repeatable. Elevate human judgment to where it matters. Measure what drives behavior. Build partnerships internally and externally. Supply chains are team sports. Keep architecture modular so you can change without breaking. Invest in security like your business depends on it, because it does. And remember that adoption is the real finish line. A capability unused is a cost, not an asset. If you're standing up a practical roadmap, begin with a few questions. Where are your costly exceptions today? Which decisions are being made with the least data and the most impact? What handoffs are slowest or least reliable? Map a handful of high-value journeys, order to cash, plan to produce, source to settle, and identify the specific points where better visibility or automation would move the needle. Pair those with enabling foundations like master data cleanup or standard APIs. Commit to short, value-focused increments. For example, light up shipment visibility on a few key lanes before trying to boil the ocean. Deploy warehouse task optimization in a pilot building before rolling out robotics. Run an S&AMP op scenario capability for one product family before globalizing. Use the wins to fund and justify the next step, and keep feedback loops tight. Finally, adopt a mindset that technology management is not a project with an end date. It's an operating capability you build and maintain. That means ongoing budgeting for enhancements, time carved out for upgrades and technical debt reduction, regular security reviews, continuous training, vendor roadmap check-ins, and a culture that expects change and learns from it. It's not glamorous to schedule a quarterly data quality review or a disaster recovery test, but it's what makes the difference between a digital supply chain that survives its first storm and one that quietly, reliably delivers quarter after quarter. The companies that treat supply chain technology as a strategic capability, thoughtfully curated, tightly integrated, resilient, and relentlessly focused on outcomes, will be the ones that turn uncertainty into advantage.